Assalamualaikum and hi everyone. Let's watch this video together. We are from group 6 and this is our group members. So, let's jump straight into this video. We chose the topic applied maximum and minimum for application of differentiation. First of all, what is differentiation? Differentiation is the process of finding a function that outputs the rate of change of one variable with respect to another variable. And do you want to know why we use differentiation? It is because we use derivative to determine the maximum and minimum values of a particular functions.
The problem statement is a manufacturer wants to make a cylindrical can to fill 0.5 liter of tomato sauce. Find the minimum dimensions that will reduce the cost of matter that used to produce the can for the tomato sauce. Given the volume of the can is 500 cm3.
From this problem statement, we have to identify first what we have to find, which is we need to find the minimum dimensions. Also, we have to identify the information that we get from this problem statement in order to help us to solve the problem. And one more important thing to remember, make sure that we use the right formulas in our solution. Based on our problem statement, it stated that the manufacturer wants to make the cylindrical can, so we have to use the formula of the surface area of cylinder and the volume of cylinder. So given the volume of cylinder is 500, so substitute 500 in the volume equation. So it will be pi r square h equals to 500. Then in this equation, we only want one variable. So remove the pi r square to the other side, so it will be h equals to 500 over pi r square. Once we have simplified the equation into one variable, we're gonna substitute h into the area equation so that we will have only one variable in the area equation. So look back at the formula area. It is 2 pi r square plus 2 pi r h. So when we substitute the h, we will get 2 pi r square plus 2 pi r multiplied with 500 over pi r square. So we're gonna get 2 pi r square plus 1000 over r, which is similar with 2 pi r square plus 1000 r to the power of negative 1. After we make the A equation to have only one variable, we need to find the critical value by differentiate the A equation, which means we're gonna find the dA over dr. So after differentiate, we will get dA over dr equals to 4 pi r minus 1000 r to the power of negative 2. In order to find the critical value, we must let dA over dr equals to 0. So we have 4 pi r minus 1000 over r square equals to 0. Then we make it as one fraction, so 4 pi r to the power of 3 minus 1000 over r square equals to 0. Simplify the equation and we will get 4 pi r to the power of 3 minus 1000 equals to 0. And then 4 pi r to the power of 3 equals to 1000. Then finally we will get the value of r, which is 4.30 cm. Next, we need to substitute r in the equation h. So it will be h equals to 500 over pi multiplied with 4.3 square. Then we will get 8.61 cm as the height. From this, we can say that h is equals to 2r, which means the height of the cylindrical can is 2 times of the radius. Even though we already got the value of r, but we're still not sure whether the value of r is minimum or maximum value. So here, we must differentiate the equation twice to get d square a over dr square. So when we differentiate 4 pi r, we will get 4 pi, and differentiate 1000 r to the power of negative 2, we will get 2000 r to the power of negative 3. Then 4 pi plus 2000 over r to the power of 3. Next, we substitute the value of r in the equation, so it will be 4 pi plus 2000 over 4.3 to the power of 3. Finally, we will get 37.72. As we know, 37.72 is greater than 0, which means when a value that greater than 0, it shows that the value is a minimum value. So here, we know that r equals to 4.30 cm is a minimum value. So the value of h that we calculated just now is a minimum value as well. Finally, we get the minimum dimensions that the manufacturer need, which is height equals to 8.61 cm and radius equals to 4.3 cm.
In conclusion, based on the problem that had been solved, it shows applied minimum and maximum is very important and useful in every situation. It can solve the manufacturer to determine the minimum surface area of the tomato sauce cylindrical can so that it will not cost much in the process of making the can. For another situation, a farmer can determine the maximum area of his farm by using applied maximum and minimum so that he can get the maximum profit from the plants in the farm.
So that's all from us. Thank you.